Trigonometry, my friends, can be divided into some pretty major chunks. And you know a lot at this point about right triangle trigonometry. So what we're going to do is try to transition over to unit circle trig. And to do that, just as a little intro today, I'd like for you to imagine some right triangles. Let's look at a right triangle with hypotenuse 1. Let's say that this is 1 unit. And let's give it a, say, a 5-degree angle. All right, I don't want to get too big of an angle, but I want to have something I can see. I could have started at 1 or any angle. So I'm going to start with a 5-degree angle and a hypotenuse of 1. So what I'm interested in specifically are the lengths of this side and this side, the x and the y. How far, if you thought of this 1 as a vector starting at the origin, how far to the right did it go and how far up did it go? And what we would use is right triangle trig to find those answers, okay? Y would be 1 times the sine of 5 degrees, and x would be 1 times the cosine of 5 degrees, right? So, for instance, if you were finding x, you would say the cosine of 5 degrees equals adjacent over hypotenuse, and then you would multiply both sides by 1, and you would get 1 times the cosine of 5. And the reason we're using 1 is so that we can just use the cosine of 5, and that's going to get us connected to unit circle trig. So what I know about this point is that the x distance is cosine 5 degrees. I'm going to make sure my calculator is in degrees, which it is. So the cosine of 5 degrees is 0.996. And we would imagine something very close to 1 because the hypotenuse was 1 and I barely moved it, so it didn't get too far to the left of where it originally was. If the 1, if it were laying flat, it would have gotten out to here, but I rotated it up 5 degrees. So y, I'm expecting a small number. So that's the sine of 5, which is 0.087. Okay, so this is just one example. That 5 could be any amount of degrees. All right, let's kind of put that one on hold for a minute, and let's do another copy of this and get another degree, see what its x's and y's are like. So I'm going to take this side and let's keep it at 1, but let's make it 10 degrees. I'm going to make a right triangle. Let's call this 10. This is still 1. So my x distance and my y distance, my cosine and my sine are cosine 10, 0.985 and 0.174. 0.985, 0.174. All right, so I have another right triangle. No big deal. Sine of 10, cosine of 10. What if we get up to a more special angle, like 30 degrees? If I get up to 30, I want to keep using this one because I want to keep it with the same height, or excuse me, with the same length. Let's say that's 30. My 10 was probably a little bit too big. I'm going to estimate that at about 30. Once we get to 30, we have created a special right triangle. And we've reviewed these recently. A special right triangle is either a 30-60-90 or a 45-45-90. At this point, the reason it's special is because I don't need to go to my calculator to figure out what the cosine and the sine of 30 are, the x distance and the y distance, the distance right and the distance up, because it's a special right triangle. The hypotenuse is double the short side, which means the short side is a half, and then the long leg is the short side times the square root of 3. So it's the square root of 3 over 2. Okay, so The cosine of 30 degrees is the square root of 3 over 2. The sine of 30 degrees is 1/2. If I type those into my calculator, cosine of 30, I don't see that as square root of 3 over 2, but you'll start to recognize that number as the square root of 3 over 2. Same thing, exactly. Okay, so that also is going to happen at 45 and at 60. So let's see what happens at 45. All right, so if that's 45, this is hypotenuse of 1. If you recall from 45, 45, 90s, to get from hypotenuse to side, you divide by the square root of 2. To get from side to hypotenuse, you multiply by the square root of 2. 1 over the square root of 2 is not ideal. We're going to rationalize that and make it the square root of 2 over 2. And in that case, they're both the same. Square root of 2 over 2. Okay, so cosine 45 is square root of 2 over 2. Sine of 45 is the square root of 2 over 2. These numbers, the 1/2, the square root of 3 over 2, square root of 2 over 2, those are very important numbers in the unit circle. I'm going to do, actually, we're good. Let's just take the ones we've got. And now we're going to transition over to unit circle trig. So what I want to do is take the various little right triangles and I'm going to put them all in the same, with the same starting point. See how this goes. It's going to get chaotic on my picture here. All right, there's another one. That one was the 10, which is probably a little bit much. Let's take the 30. And then let's take the 45. I'm going to leave off, I just want the triangle mostly. And that one was a little bit, drew it a little bit too long. So, see if I can get that one back in line. And what you get with all of this mess that's all cluttered up is the startings of a nice unit circle. So let's get some axes. So let that starting point be the origin. And then if you see those, as I progressed up from 5 to 10 to 30 to 45, what I'm making is a circle centered at the origin with radius of 1. All right? So all the unit circle is a bunch of right triangles all squished together, and all of these ending points, kind of like the ending point, the terminal point of a vector, they go together to form a circle. All right? It's called a unit circle because it is 1 unit in radius. All right, and that unit could be any distance. You know, if you draw it on your paper, it's probably about 1 inch. If this is, I don't know, some sort of big circle, a round track or something, maybe it's, 100 yards. I don't know. But 1 unit, it could be anything. That's not the important part. The important part is that it is 1. And what we're going to do is try to figure out, it's all based on sine and cosine when we do unit circle trig. We'll find tangents and cotangents and secants and cosecants. We'll do all of that stuff later. But the important thing is, what are the sine and the cosine of any point around the unit circle? So I've done some here. I could do 70 degrees, which would be up here somewhere. Sine and cosine will give me the x and y coordinates of that point. Cosine of 70 degrees. It's an actual literal x coordinate, okay? It's how far over this point is, that distance right there. Sine 70 degrees is the vertical distance, all right? If you judge by my point, I should expect sine of 70 degrees, since it's pretty steep, to be a number that's pretty close to 1, because this is a height of 1, and sine of 70 is way up here. And I estimated 70, but I'm fairly confident that when I do sine of 70 in my calculator, I'm going to get something at least 0.9, probably higher. Yeah, it's 0.94. So one thing you've got to grasp is that sine and cosine, they're ratios of sides, but in the unit circle, they're actually distances. Distances to the right or left of the origin, and distances up or down from the origin. Okay, and then we're going to focus to start on this first quadrant with the angles 0 through 90 degrees, but this thing goes all the way around. When it kind of breaks off from right triangle trig is when we get, what if the angle were 150 degrees? Then we're over here where the 150 is over here, and we still do sine and cosine of 150 to get the x and the y coordinates of that point. All right, if it can go on past, 260 degrees, it would be down here. That's all the way around 260 degrees. The sine of 260 is going to give me this distance right here. Excuse me, that's the cosine of 260. The sine of 260 is going to be this distance right here. All right, it works all the way around. It'll work once you get past 360. The sine and cosine of 400 degrees are going to be, where's 400 degrees? Well, let me get a new picture. This one's starting to get cluttered. 400 degrees would be all the way around once. And then 40 to spare, right? 360 is all the way around. So right there is 400 degrees. All right, we spin all the way around to 360, then we have 40 left. We'll talk more in detail about this angle right here. This 40 is called a reference angle and all that. But if I go into my calculator and I type the sine and cosine of 400, let's do cosine first since x usually comes first, I get 0.766 and 0.64. 0.76, 0.64. That means the coordinates of this point are 0.76, 0.64. So I didn't quite get it high enough, I don't think, but that was close. All right, that's an actual distance right here of 0.76 and a distance right here of 0.64. All right, so there's not a lot of skills involved that you need to be able to do in this video. I just want to get the connection, get it a firm base before we start into this unit circle business, because we're going to spend a lot of time and do a lot of work, and it's all going to be based on this circle, and you need to understand what's happening with it before we get into all that. All right, so remember, all it is a bunch of little triangles that form a circle when you put them all together. And it doesn't just have to be whole numbers or 5, 10, 30. It's 1 and 1.2 and there's infinitely many triangles that go into this thing. All right, so we're going to call that an intro to unit circle trig. Young out.